So now let's get into the concept of what a function is. All right, we just talked about what a relation is. A relation is any time we pair input numbers with output numbers. But a function is a slightly more refined definition. But I think to explain this well, I actually want to explain what isn't a function. Okay, so here I've put something that's not a function, and what I would consider a non-function. Time versus distance. So this line right here tracks somebody's distance over a certain period of time. All right, but I want you to take a moment to take a look at it and tell me if you can think of what's wrong with this. Because in this graph right here, this actually can't happen in the real world. But why? All right, so basically I'm kind of hoping you spotted this area. I'm going to actually grab this little line right here. Okay, so imagine this is just some line that the computer tracks over time. So as you can see, if I start dragging this bar across time, you can see the distance increasing. The further I drag it over, the higher this little intersection point gets. And again, further in time, further it goes. But then you get to around here. Okay, why doesn't this make sense? Okay, well, think about what the graph is telling you. They're saying at this particular moment in time, I'm this far away. I've covered this much distance. But then if you look up here, it also says I've covered this much distance. That doesn't make any sense. Basically what this graph is saying is that at this particular moment in time, I'm in two completely different locations. I'm at two completely different distances. And that just can't happen. Okay, and so this is not a function. It's a relation because I paired time with distance, but does it make sense? No, this can't happen in the real world. In fact, if I keep going and I move the bar even further to here, that's telling me at this point in time I am at this location, that distance, this distance, and this distance. Now I'm three different places at once. Okay, and this can't happen in the real world, and that's exactly why we call them functions. Okay, what we see or what we look at should be functional. It should work. This can't work in the real world, so it's not a function. Okay, so that's the difference between a relation, anytime we just pair numbers together, versus functions. A function has to be functional. It has to work. Okay, so some relations like this one don't work. And in this particular case is because I can't be in two or three places at the same moment. Okay? Okay, so here's our definition. A function is a relation, but it's a relation that works. And the way you can tell whether or not it works, what we're specifically looking for is that a relation that's a function is a relation where each input is paired with exactly one output. Okay, so think about back to our graph why that makes sense. If I were to drag this bar across, so far this graph makes sense. For every input of time, I have a single output for distance. As I move this bar across, that doesn't change. But the only time this became not a function was where we hit here, where this input of time down here on the x-axis spit out two different answers for the distance. If I went further, this input for time gave us three different outputs. And so a working function should always have a single input spitting out one output answer. Okay, oh, by the way, in case it ever comes up, in different books, when dragging this line across to find these points where you get different outputs, sometimes you'll hear it referred to as the vertical line test. Okay, our book may or may not refer to it like that, but yeah, you can kind of get the idea. If you run this vertical line across and you hit a point like this, you can see, oh, this fails the vertical line test because I have one input spitting out two different outputs here and here. Okay. All right, so now your job in this unit, this lesson, is to be able to spot this. Now with a graph, it's kind of easy. You kind of look for that spot where, wait, this can't make sense. I'm in two different places at the same time. But what about a table? All right, so take a look at these tables. I've got time driving versus distance. Okay, this one is a function because it makes sense. At time 0, I've traveled a distance of 0. At, let's say, 1 hour, I've traveled 15 miles. Hour 2, I've traveled 20 miles. Hour 3, I've traveled 60 miles. Hour 4, I've traveled 68 miles. Now, have I traveled at a consistent rate? No. But again, we don't care about linear anymore. We just want to know, is this a function or not? And in this story that this table tells, it seems to all work. I don't see a single place here where the story doesn't make sense. But now take a look over here, especially these ones I've labeled in red. Hour 0, I've traveled 0 miles. Hour 1, I've traveled 15 miles. Hour 2, I've traveled 20 miles. Hour 2 again, I've traveled 60 miles. This doesn't make sense. How can I have two different 2-hour inputs spitting out two completely different answers? It's basically saying that at hour 2, again, I'm at two different places at the same exact time. It just doesn't make sense. Okay, so this is not a function. It's a relation, but it's not a function. This one is a function because the story works. It makes sense. It's functional. All right, so let's work on our definition. Why don't you pause the video here and take a look and see which of these are functions and which of these are not. All these relations are written as tables, but out of all of these, only 2 of them are functions and 1 of them is not a function. So take a moment, maybe pause the video and see which one you think is not a function and which are the 2 that are functions. All right, so let's take a look. Let's take a look at this first one. Now again, what we're looking for, according to our definition, is a function is a relation where each input is paired with exactly 1 output. Okay, so take a look here. 2, let's say this was time and distance again. Hour 2 spits out 15 miles. Hour 3, 22 miles. Hour 8, 57 miles. Hour 5, 36 miles. Hour 7, 50 miles. Okay, is each of these inputs spitting out 1 output? Yes. All right. Now, is it a little weird that this one in particular is out of order? Sure. But, I mean, we could fix that. If you just wanted to put that here back in sequence, we'd be fine. Okay, but again, what we really care about, even though it's out of sequence, is does each of these inputs spit out only 1 answer? And the answer is yes. So this one is a function. Okay, now let's look at this second one. 1 spits out a 3. 4 spits out an 8. 6 spits out 9. 2 spits out 4. Whoops. And 4 spits out 7. Is this one a function? And again, the fact that it's out of sequence we don't care about, but what we're looking for is does each input spit out only 1 output? Okay, now in this case the answer is no. I'm hoping you spotted it right here. Here you've got at hour 4 spitting out a distance of 8 miles. And here at that same hour 4 spitting out a distance of 7 miles. This is again the same thing that this graph was telling us. It's telling us that at hour 4 we're at 2 different locations at the same time. That doesn't make any kind of sense. So it's not functional. This can't happen in the real world. So not a function. All right, let's take a look at this last one. All right, 0, 12, 1, 14, 7, 60, 1, 14, 4, 35. So is this one a function or not a function? Okay, well, some of you may have spotted this one and this one and originally thought, oh, that 1 appears twice, so this is not a function. But if you take a look, this one is spitting out a 14, and this one is telling us the exact same thing. So I've got the same input spitting out the same output. It's basically what happened is somebody just recorded the data twice, so we didn't even really need this one. Okay, but is it a function? Yes, because what we care about is that we just don't want one input spitting out 2 different outputs. So this is okay, and so this is still considered a function. All right, so that's what it looks like in terms of a table.